came up was this question 10 on that C3 differentiation 1. So let's have a look at that. So it says the diagram shows a cross-section of a vase. The volume of the vase is given by that equation. Initially the vase is empty, so this is rates of change, which we will be looking at. So we know that when t is 0, so I'm just going to make a note of these things. So when t is 0, I know that the volume is also 0, and the depth as well would also be 0. That would also be 0. And it's poured in at a constant rate of 80 centimeters cubed per centimeter squared. So when you have the units, if you're unsure about what units will work, so unsure about which parameter it is, look at the unit. So centimeters cubed is volume, so it's not depth. Depth would just be centimeters, it's just a height. So it's volume there. So that's telling us the number, so the one with the positive power is the thing that goes on top, the one with the negative power is the thing that goes on the bottom. And we know for rates, it's normally in respect to time when you're looking at things like this. So if something's being poured at a rate, it's looking at how much is flowing in per unit of time. So what I'm actually going to write that is I'm going to write that as dV by dt. So this is what we mean about rates of change. We're looking at how something changes with respect to something else. We know it's a rate of change. So gradient, for example, is a rate of change. Differentiation is basically rates of change. So dV by dt is a constant, so that doesn't change. So it's 80 centimeters cubed per second. So we know that. It says find the rate, the depth of the water. Find the rate at which depth of the water in the vase is increasing. A at when h is 4. After 5 seconds of it being poured in. So let's have a look at part A. So I know dV by dt. I essentially want, if I want the rate which the depth of the water is changing, I am trying to find dH by dt. So I know I have dV by dt, and this is where I can use chain rule to basically try and form dH by dt. So to form dH by dt, I know I want a dH on the top, and I want a dV on the bottom, so they cancel out. So I want to basically multiply that by dH by dV, and then the idea is that the dV's cancel out, leave me with dH by dt. So I already have dV by dt, I don't need to worry about that. So I need to find dH by dV. Now you might think, how do I do that? Well, what we can do, we might struggle with that, but what we can find is this. So I'm told at the start of the question what the volume is, and that has a h in it. So I'm told that V is 40 pi e to the 0.1 h minus 1, and then we are going to differentiate that with respect to h. So when I do that, so ignore, obviously the constant is just going to stay as it is. So the 0.1 h, so the 0.1 is just going to come down when we differentiate that e to the 0.1 h. So I'm just going to make it 4 pi h when I bring that down, because that's just the same as multiply by 10, isn't it? So that'll be 4 pi e to the 0.1 h. That should be a 1 there. And then we know the 1 is just going to disappear, isn't it? So that leaves us with that. So it'll be 4 pi 0.1 e to the h. That's dH by dV. And then, again, the idea sort of comes from chain rule. dV, dH by dV, I'm basically just going to flip dV by dH over. So that means dH by dV is 1 over that. So it's 1 over 4 pi e to the 0.1 h. So I now have my dH by dV, and I had my dV by dt because that was just 80. So therefore, if I want to find dH by dt, where's my pen gone? Lost it. There we go. Don't know why it keeps making me do that every time. So dH by dt, so I'll just rewrite that so you can see where it's come from. So we know that's going to be dV by dt times by dH by dV. dV by dt was at constant rate of 80. And then dh by dv is 1 over 4 pi e to the 0.1h. Okay, so then let's just tidy that up. So it will be 80 over 4, which is 20, I believe. So I believe that will be 20 over pi e to the 0.1h. I am questioning if I've done 80 divided by 4 correctly. I'm pretty sure I have. So there we go. So we end up with that as our dh by dt. So now it's just a case of substituting in, because remember the whole point we're doing this is to try and find the rate at which the depth's increasing when h is 4. So we know this is dh by dt. So now so that's dh by dt. So let's put in h is equal to 4 now, because that's what we needed. So pen, let's make sure I'm actually using a pen. So h is equal to 4. So that means it will be, so dh by dt will be 20 over pi e to 0.1 times by 4. So that'll just be 0.4. And then you just need to sort of put that in your calculator. It's not going to give you a very nice number. It'll give you 4.27. And then units wise, let's think. So it's height, which is centimeters. I guess I called it depth before. I'm calling it height. It's the same thing. And then time is seconds. And remember, you're sort of dividing by the seconds. Seconds on the bottom. So it'll be s to the minus 1. So 4.27 centimeters per second is that rate of change. So that's part A. Then part B, it wants to know the rate of change after 5 seconds of pouring in. So I basically need to find out what h is when t is 5. That's what I need to find out here. So h when t equals 5. So I need to think, how can I find h when t is 5? So I know I've got an equation for volume, but that's with respect to the height, isn't it? So I do have an equation relating volume and height, and I also know dv by dt as well, don't I? I also know that. So dv by dt, I was told, is a constant rate of 80, isn't it? So where's my pen? So dv by dt is 80 centimeters cubed per second, and this is where you sort of got to use a bit of common sense. So the vase is filling up 80 centimeters cubed per second. So realistically, I can find what the volume of that vase is, because I know it's just going to be each second we're going to get another 80 centimeters cubed in there. So I can find volume when the time is 5, and if I know that, I can then relate that to the equation involving volume and the height. So I think the v, so v when t is 5, I can say this. Well, I know it's 80 centimeters for each second that the water is being poured in, or whatever the fluid is, I can't remember. So it's going to be 80 times by 5. If you wanted to, you could do the whole integration-y thing and then integrate 80. It's going to become 80t between the limits of 0 and 5. It's going to give you the same thing. But I just think logically, if it's 80 centimeters cubed per second, 5 seconds, 80 times by 5. So it will be 400 centimeters cubed is what our volume is going to be. So now I know what the volume is in 5 seconds. So if I've got an equation relating volume and height, which I do, I can then find what the height is. So the first initial equation we're given is this one right here. We're given that v is 40 pi e to the 0.1 h minus 1. So I'm going to set that v to 400 because I know that's what the volume would be at t is 5. So if I divide through by the 40, that's just going to get 10, isn't it? And I'll divide by the pi as well. So I get 10 over pi is equal to e to the 0.1 h minus 1. And then it is just a case of, oh, my things come off my pen. I'll deal with that later. So it is a case of then just rearranging that so we can keep going, but it's basically going to become, if we add the 1, so it's going to become the natural log of 10 over pi. I don't know why my pen is not working properly. 10 over pi plus 1, and then divided by 0.1, which is the same thing as multiplying it by 10. So I think h is that thing there, which isn't very nice. So you're going to have to put that in on your calculator, and it gives you, I think that gives you a height of 14.31, roughly. And then that would be in centimetres. I like to make sure things have got units on, even if it doesn't specify, because you never know what they're going to give and take marks for. And I think it helps your overall understanding of what's going on in this situation. So now the final thing to do is to bung that in dH by dt, which we found before. So dH by dt, which I don't remember what it is, so hang on. Where was dH by dt? dH by dt is 20 over pi e to the 0.1 h. See if I can remember that by the time I scroll down here. So 20 over pi e to the 0.1 h, and then we're then just going to put in h as 14.31 centimeters, and that will get us a dH by dt. When we do that, is going to equal 1.52. And that will be now centimeters per second again, because again, it's a change in the height or the depth of the vase in relation to time.